Okay? So that's why I'm saying I think that default should not be any object, because that's a pretty rare case where two different kinds of UI elements are sending the same thing. So why do the rare case? Even though that's the more generic or more general case, I agree, it still just seems kind of error prone to me. But anyway, so there's another any object example. So here's one more any object thing. Let's go back to that button thing. So I told you the button with type returns any object. Okay? And so if I got a button and I wanted to find out its title or something like that, I have to cast it. So I would call I would call that button with type, and I can cast on the fly, right in line. So if I called that line on green at the top, then down here I could say the title of the button equals button as UI button dot current title. So I'm just casting that any object, that button any object up there to be a UI button, and then sending in a message. So you can cast on the fly. Again, crash-a-roo if that button is not a button, but that's okay. In this case, button with type better darn well return a UI button. Okay, now this casting business is not just for any object. You can actually cast any two objects. For all non-any object case, though, obviously those two objects would have to be in the same inheritance hierarchy, right? You can only cast down, downcast into your own inheritance hierarchy. So, for example, if I had a local variable called VC, which was of type UI view controller, but I set it to calculator view controller, okay? I couldn't say vc.enter, right? Enter is a method in our calculator view controller. I couldn't say vc.enter because VC is a UI view controller. So as far as Swift knows, it doesn't respond to enter. Even though it is, in fact, a calculator view controller, from Swift's point of view, that local variable is not. It's of type UI view controller. But I could cast it and say, if I can let the calc VC equal VC as a calculator view controller, now I can say calc VC.enter. Okay? So you can cast, downcast through your inheritance hierarchy as well. You rarely do that, but might occasionally. All right, so let's zoom on here to any questions about that whole any object thing. When you see it in action, it'll make a lot more sense. Okay. Okay, so now let's just talk about some fun functions throughout all our classes, and we're going to start with array. First of all, that you know that array does plus equals. You can say array plus equals, but the argument to plus equals is another array. Okay, so if you just want to add one thing to an array using plus equals, you would have to put it in another array, just square brackets, put the thing inside, okay? Some people get tripped up by this. They do plus equals, they have an array of ints, and they say, my array of ints plus equals an int, and they're like, wow, why doesn't it work? It's because plus equal only adds whole arrays to other arrays. It's an array concatenator, okay? There's a couple of interesting variables, properties in array, first and last, that will return the first or last item in the array. What's interesting about them is that they return an optional. So they don't do array index out of bounds. So they'll return nil if your array is empty. Okay? So you should know about these because they can make your code read really nicely sometimes. So for these next ones, I'm going to have a little example array here. This is going to be an array that's got 3 things in it. I'm not even going to say what the types of those 3 things in there. They could be anything, okay? Because array is generic, right? Array angle bracket T. You can assume for the purposes of this, they're of type T, whatever the T is that I created the array with, right? So let's talk about, about append. That's how you add something to an array. We did that in the calculator all the time. There's also insert. So you can insert something in the middle of your array. You just specify what index. There's also splice. Okay, splice will take another array and splice it into the middle of your array. Okay, so that can sometimes be valuable. It's otherwise just like insert. It's just like inserting another array inside the array. Okay. There's also remove add index, of course, if it's a var. If you've got your array in a var, you can do remove add index. There's also remove range. Okay, so you can specify a range with the dot 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 thing or the dot dot less than thing and remove a range of your array elements. And there's also replace range. And when you replace a range, the thing you replace it with doesn't have to be the same length. So I can have an array and replace a range that spans 3 things with something that is 6 long and it'll make my array longer. Okay? So we can replace range. There's also sorting. You can sort an array. This sorting method in array takes one argument, and that's just a function to determine whether two things are ordered before each other or not. Okay, so it's going through the array and putting everything in order. It needs to know, it picks out whatever sort it's using, quick sort, or I don't know what sort it's using in there, but it needs to be able to compare things. So you just provide a function that does comparison, and usually you're going to do it with a closure just like this. You can see this is kind of the default sorting, assuming that this type can just be compared with less than. I would just say a.sort, closure, $0 less than $1. Make sense? And that's going to return yes if $0 is less than $1, and that's what sort wants to know. And it's going to call that closure repeatedly, okay, as it's going through doing its quick sort or whatever. There's also another one called sorted. This is an in-place sort, right? Sorts the array in place. Their sorted will return a new array that is sorted. Okay, a copy of your array sorted. More array methods. Okay, so these three are pretty cool. This one's called filter. So filter will give you a new array with all the undesirable elements filtered out of there. And the way you specify which ones are all undesirable is with the argument, which is a function that just returns a bool, whether something's undesirable or not. Make sense? And there's another one you can do by mapping. So this will give you a new array where every single element in your array is mapped to something else. And the thing you map it to doesn't even have to be the same type. So I could have an array of ints, and I could map it to an array of strings. And that's what I've done here. So I have this array of ints, 1, 2, 3, and I've mapped it using a closure that returns the stringification of it to an array of strings. Now, you can see incredibly concise language, Swift. I mean, to take an array of ints and turn it into an array of strings, no for loops, no nothing, just, I don't know, a dozen characters here. So you really want to take advantage of some of the things Swift can do with closures, syntax, and things like that. You can also reduce an entire array to a single value. So this one takes an argument which is the initial value you want to start with, and then it just takes a function that takes the value so far and the next element in the array, and you return what the combination is. So you're just combining, combining, combining. So for example, if you wanted to add it up an array, you could say 1, 2, 3, dot reduce, start with a 0, and then my closure is just going to add the next element, which is the $1, to so far, which is $0. Okay? All right, string. So string is a little bit complicated. I can tell by the way already I'm not going to get to the end of this, so we'll finish this next Wednesday on this whole slide package here. But so string is complicated when it comes to indexing, creating substrings and stuff like that. A lot of people are like, oh, I can't even figure out how to make a substring of a string in Swift. It's so complicated. But once you understand that strings are made of Unicode characters, and when you get a substring, you don't want a substring of Unicode characters. You want a substring of Unicode characters that are on glyph boundaries. A glyph is something you perceive to be a character. But in Unicode, it could be multiple characters making up one glyph. For example, an accent. So, a lot of European languages, there's accents. Okay, maybe, in French you have accent aigu, right, which is the forward-going top slash. Well, that could be two Unicode characters, E and the accent character. So two characters makes what you perceive to be one glyph. So you can't index into this string, which is an array of characters. That's what a string is. A string is an array of, essentially internally, a collection, ordered collection of Unicode characters. You can't really index by int, or you might be halfway through the accent aigu, and you're getting, either the accent aigu or the E, but not the character. So instead, strings are indexed by this other type called string.index. Okay, now how do you get a string.index? Okay, well, yes, it's saying here. Okay, so you get a string.index by getting the start index of the string. That gives you a string.index that points to the first character of the string. And then you advance it forward however many times you want to go. So in other words, you have to look through the characters so that it'll jump over E accent aigu, both characters, to the next one, you see? So you do that with this function. It's not a method in string. It's actually just a function, a global function called advance. And you give it the index, okay, and you tell it how many times you want it to move forward, and it will give you back a new index. So here's an example. I have a string that says hello. Okay, I want to get the index of the L, the first L. Okay, so I say let the index equal advance the start index of that string, go forward 2. Okay, so now it's pointing at the L. It went forward 1 to the E, now forward to the L. And again, if that it was EX on the U, it would have gone forward 4 Unicode characters, but only 3 to the third glyph as you perceive it, okay? So now that I have a pointer to that L, I could use, for example, a nice string function called splice. So splice is just like the splice in array. It will splice a string into the middle of another string, okay? And I'm going to have it splice at that index, and that's going to make it be HE ABC LLO. Splice the ABC right into the middle there, okay? So the start index is the magic behind making that work. Also, if I got 2 local variables, start index and end index, which I made by taking advance of the start index by 1 and 6, so this is going to be, I want to be from index 1 to index 6, then I could get a substring. And I get a substring in a string exactly the same like in an array, square brackets, string, square brackets, but inside that square brackets goes a range. And the range, the dot, dot, dot thing, has to have a string dot index on the left and a string dot index on the right, not ints. Okay? So here I got a string dot index by doing this advance for the left and a string dot index on the right. And so the substring will be EABCL because I went from index 1, which is the second character, index 0 is the first, or to index 6, not including index 6. Okay? Everyone understand string dot index now? It's all about advance. Okay? The advance function is the key to understanding how to substring strings. And there's lots of other, once you understand this, there's things like range of string. Remember we used range of string in calculator, and I told you it returned nil if it couldn't find it. Well, what does it return if it could find it? Well, it returns a range of string dot index. Actually, it returns an optional range of string dot index. Okay, that's how, if you used it for your assignment, that's how you used it. You used the optional nature of it, but now you could even use the range nature of it. So for example, if we wanted to get the whole number portion of a string that had a number, so I have, let's say, 56.25 as a string, I want to get the whole number part, I could just say, find me that decimal point, okay, and that's going to return a range, if it can find it, if there's a decimal point in there, it's going to return that range. And I'm going to grab the part from the num's start index. You see the num is the number, its start index, all the way to where the decimal is, not including the decimal. Okay, now I got the substring, which is the whole part. Everybody cool with that? So substringing and string is actually, once you understand this whole index thing, pretty powerful. We could even remove the whole number part, okay, just by using remove range of that same range, not start index to the decimal range. Or we can replace the range with other things, etc. Okay, so there's a lot of string methods there for doing that, and they're all based on that string index. Okay, other string methods, I'm going to start blasting through a lot of this. You can look these all up in the documentation. Some of these it actually gets from NSString, which I'm going to talk about in a moment. You can see that you can find the end index. There's that join I talked about before. Notice that there's 2 int, but not 2 double. Why is there 2 int in string and not 2 double? Anybody have an idea why that is? It's because when you convert to a double, you have to specify things. How many significant digits do you want? How many digits after the fraction do you want? Things like that. And so there's really nowhere to specify that. It would have to be 2 double with a whole bunch of arguments to specify how you want to do that conversion. When you convert to an int, there's nothing inside. You just convert it to the int, right? To the whole number. So, but notice that 2int does return an optional int. That's because if you say 2int, if you send that to hello, it's going to be nil. Okay? So, string methods. All right. Okay, there's kind of a hidden bunch of methods that you don't even know about, which is conversions using init. So, for example, if I had a double and a float, I could say let x equal int of that double. And I just basically created a floor and turned it to an int. So I converted it. So you convert things and convert them from one thing to another. It makes total sense with the number values like ints and floats and things like that. And you're going to see CG float next week. That's another kind of floating point number. And you can convert using, there's no toInt or anything. You just create a new one. with the initializer, okay, so the numbers. But you also might be surprised, actually if you read the homework carefully, or the reading assignment, you saw this, is that you can convert arrays and strings using these initializers. For example, you can say array of a string, so create a new array, and the initializer's argument is a string, and it will return you an array of all the characters in that string, right? Unicode characters. Or vice versa, you can have an array of Unicode characters, right? And it will, and you pass that to strings constructor, and it'll return a string with those things zipped up. Okay? So there's kind of a hidden thing there. Notice that you can't do string of 52.5, but that's okay because you have that backslash open parentheses thing to convert floats to strings. Okay, you can do string of 52 though, because it has 2 int, it kind of knows how to do that. All right, assertions. So assertions, really valuable debugging aid. They basically take a closure as the first argument. It's an auto closure, which means you don't need the curly braces. It's kind of a funky thing, okay? So the first argument is what would be inside the curly braces of a closure. And the second argument is some string that's going to be printed out on your console, because assert, if whatever that thing that was in the auto closure evaluates to, if that's not true, okay, because you're asserting that that's true, then it's going to crash your program. Okay, and print that message out. So it's a great way to make your program crash when things that should be true aren't. Now, asserts don't work when you build your program for release, like to the App Store. When you're shipping to the App Store, asserts don't work. It doesn't even evaluate the closure, okay? It's just ignored. But for debugging, it's pretty good. So I might have a function called validation that should, at this point that I'm executing this assert, not be returning nil. And if it does return nil, then I'm going to crash here. So I say the assertion is that validation should not be nil right now. Okay? So a lot of languages have assert, so Swift does too. Okay, other functions. So there's a lot of functions, and these do not appear to be documented anywhere yet. So this slide might be your only documentation. I'm sure you can find about them on the internet and stuff too, but there's a lot of functions. These are global functions, not methods. They take arguments which are hard for me to explain to you right now, but basically they take arrays and strings and dictionaries, because they take other things that arrays and strings and dictionaries are, those things. But you can look through this list, kind of interesting things. I can combine it with the thing I was talking about at the end there, with the string, passing an array of characters. I can actually take a string, call reverse, which returns an array of the characters reversed, and then call string to push it back and call it, create a string again. All right. Objective-C compatibility. You know what? We are going to wait and talk about this next time. Very important topic, but I don't want to give it short shrift. So that is it for today. Let me quickly show you this slide. Okay, coming up, no Friday section this week. Next Monday is holiday, no lecture. Next Wednesday, I might not be talking about auto layout next week. I'm not sure. Your homework 1 was due today. Your homework 2 is already posted. Your reading assignment 2 was posted on Monday. All that stuff is due next Wednesday. If you have any questions, I'm here.
For more, please visit us at Stanford. Stanford University.
Okay, well, welcome to Lecture 4 of CS193P, Stanford, winter of 2015. So I've been doing all demo up until now, and now we're going to be doing all slide today. So I have a lot of stuff to talk about. Most of this, although not all of it, is covered in your reading assignments, okay? But here I'm going to try and highlight the things that are pretty important, and also show you some stuff that's just not in that reading assignment that you kind of need to know. So this is definitely not a substitute for the reading. You'll still need to do the reading in order to kind of get the details of a lot of this stuff. So, but this hopefully will kind of get you focused in on the key stuff. All right, so first I want to talk about optionals and enums. So now that you know what an enum is, I can tell you what an optional really is, okay? An optional is just an enum. Okay, it's a very simple enum. It's a generic, kind of like array. You know, have an array, you specify the type of thing in it. Optional is exactly the same. Okay, it's a generic. You specify the type of optional, and it is. And that type, which is T here in this little enum, is just the type of the associated value. You know that enums can have associated values. So that's just the type that if the optional is not nil, that's what you get. So that's all an enum is. And so, for example, this is what it would look like if we used the enum notation to do an optional. Saying, you know, x, which is an enum, or it is an optional string equals nil, would just be saying x equals optional angle bracket string dot none. Okay? Or if you're setting it to not be none, you would say optional angle bracket string dot sum, parentheses, the associated value, which would be hello. Does that make sense? So optional is really actually super simple. The question mark and the exclamation point, I know that makes it seem like, whoa, it's really complicated, but it's pretty simple, really. It's just syntactic sugar to do this optional. Now, the unwrapping really just looks like this. It's just a switch. And in the case of sum, you give the value back. And in the case of none, you raise an exception. Okay? And simple as that. That's why it crashes when you unwrap something that's nil. Okay? So that's optional. All right, so array, I just want to, we covered this, so I'm going to go really fast through this, but arrays, the syntax there is the same, right? That square bracket thing, that means exactly the same thing. Also, you can't append or modify in any way an array that is a let, right? That's a constant array. I just want to make it clear that defining an array to be a constant by saying let something equal an array versus var something equal an array means that it's immutable. So you can't do append or insert or anything else that you could do on a mutable array. Also, of course, if you access an array with the square brackets and try to pull out something that's outside the bounds of the array, this array only has 4 animals in it and I'm trying to get animals 5, that's going to crash. Array index out of bounds, just like pretty much any language you've used. How to enumerate an array. If you wanted to go through every single item in an array and look at it, you can use for in. Okay, so you just say for some variable you want in your array, and then inside there, that'll be your value. Okay, pretty obvious. I put this here mostly to compare it to the next slide, which is dictionary. So dictionary, again, that square bracket thing is an alternate for the exact same thing. So if I had a nice dictionary here, I can create a dictionary using this square bracket notation, which is just square bracket, key colon value, comma, key colon value. Okay, you know that. And you also know that if I access a dictionary with the square brackets, it returns an optional. And that's because, for example, here, I'm looking up Pac-10 team Ohio State. Obviously, that is not a Pac-10 team, so it's not in the dictionary, so it's going to return nil. Okay, so that's why when you access a dictionary, it comes back, it's an optional. To enumerate a dictionary, you use a tuple. Okay, so you say for the tuple, key comma value, in the dictionary, and then inside there, key and value will both be set. Okay, so that's really easy way to enumerate dictionaries. Make sense? All right, I'm going to teach you about a new struct that you haven't seen called range. A range is just 2 points of a sensible type. So a starting point and an ending point is exactly what you think a range would be. Now I say sensible type here because, you know, the sensible type depends on what you're talking about. For an array, the sensible type is an int, but for other things like a string, it's not. And we're going to talk about that in a minute. Range is also a generic, just like array or like that optional enum. And so it takes the type of thing. So the range, again, to specify a range in an array would be range angle bracket int, because ints are how you index an array. So if you were going to specify a range in an array, they would be ints, okay? And it's approximately what I put here. It's not exactly this, but as far as given what you know so far, this is the best I can describe it to you. It's just a struct that has a start index and an end index. And it is a struct. You can go and get those values and set those values out of there. So array's range would be array of int, range of int. String, you would think that a string would also be subranges of strings would also be specified by an int, but it's not. There's a special type called string.index, which is an index into a string. I'm going to talk all about that in a later slide. Okay, so ranges, just like arrays and dictionaries, we don't usually say range angle bracket int equals something. We use this special syntax, and the special syntax is this 3 dots or 2 dots and a less than sign. Okay, so the 3 dots means a range from the first thing on the left of the dots to the other thing on the right of the dots. That's the start index and the end index, and it includes them both. Includes both the start and end. Whereas the other one, 2 dot dot less than, means it includes the first one, but it does not include the second one. So it's an open-ended range. Okay, because both of those kind of ranges are common. So that's how we specify a range. 99% of the time we don't use the range struct to do it, although you could create a range struct and you could pass it as an argument to anything that takes these dot dot dots. You could put an actual range in there as well. Okay, they're the same thing. It's just the dot dot dots are syntax to create that range for you. Okay, and the things on the either side of the dot dot dot, it depends on what kind of range you're kind of creating. If you're creating an int range, a range of angle bracket int, then they'd be ints. Okay, but if you're doing a string, they have to be string.indexes. And that's a little harder to create because a string.index can't be created from a numeric literal. You have to create it programmatically. So we'll talk about that in about 10 slides or so. And you can enumerate a range using for in, just like we can with arrays and dictionaries there. Okay. All right, other classes besides arrays, dictionaries, range. NSObject. So NSObject was the base class for all Objective-C classes. In Swift, we don't really have a base class for all Swift classes. However, there are some kind of advanced features in iOS that require even your Swift class to inherit from NSObject. I can't really talk about them because there's other things you need to know for me to even explain them to you, but down the road that will happen. It really doesn't hurt to make your Swift class be a subclass of NSObject, so we could have made Calculator Brain be a subclass of NSObject. It wouldn't have hurt, and in the future, once we learn these advanced things, it'd be nice to be able to do those advanced features with Calculator Brain. So it's kind of one, you can feel free. I'm not sure what to say the best practice here is to always have your Swift classes inherit from NSObject. All the classes in iOS, like UI View Controller and all those, they all inherit from NSObject eventually. It's the superclass of all of them. There's not really much in NSObject anymore that matters. But like I say, there's these advanced features. But then there's NSNumber. You've actually briefly seen NSNumber. NSNumber is just a generic number holding class. It just holds a number. That's all it does. And it has a ton of methods on it. I'm not going to go through them here. You can look in the documentation. But the methods are things like double value, int value, which is give me your value of yourself as an int, as a double, etc. In Swift, we don't really use this very much because it's strongly typed, and so we're using types like int and double. But in Objective-C APIs, there's NSNumbers lying around, and so you kind of need to know about it. I'm going to talk a little bit later about the fact that all those Swift types are kind of magically bridged to NSNumber, okay, those ints and doubles. So you really don't even have to worry about NSNumber. Unless you're going to use something like the NSNumber formatter that we used in the assignment, okay, because that thing returns an NSNumber. Yeah.
So if there's no like NSObject parallel in Swift, is there a way to make like an array that holds any kind of?
Yeah. So the question is, if there's no NSObjects, well, it wouldn't really matter about NSObject, but the question is, can I create an array where there are random objects in there? And we're going to talk about that later. Another class, NSDate. Exactly what it sounds like. Stores a date, lets you get the current date and time too. Pretty self-explanatory, has lots and lots of methods in it. And it has even more and more methods because there's those 3 other classes mentioned here, calendar, date formatter, and date components. And if you're ever doing a date where you're going to put a date on screen as part of your application, you really want to look at all these classes and read the documentation that talks about dates, because dates are displayed very differently around the world. Different calendars, different, even different languages. The order of the month, day, year, even if you're using the Gregorian calendar, is different. So you really, dates are tricky to get right if you want to build an app that can work around the world. Okay, so I'm just kind of warning you, if you're going to build an app like that someday, you want to really understand date and all its friends here. There's NSData, super easy class. It's just a bag of bits, okay? Could be a gigantic bag of bits, small bag of bits, whatever, but it's just untyped data that's just in there. You can think of it almost like a pointer to memory, and you just don't know what's in there. This is how iOS will pass around untyped data, raw data. It passes it around using this class. It'll be obvious when we start using this what it's for. You're not going to be using NSData much in this class because we're not dealing with raw data that much. Okay. All right, so I just wanted to mention some of those classes just so you know they exist. You can check out the documentation on all of them to find out more about it. And I'm going to revisit a few of them like array and dictionary and string because they're so important. I'm going to actually talk about some of their methods. But I want to talk a little bit about data structures in Swift in general. Okay? There's really three